Had another DAT machine come in. This one's by Tascam. It's a dual DAT, and I have never seen a dual DAT, but it actually is two completely separate DAT mechanisms in the one case. It has a single set of inputs. It has two sets of outputs on it, and this one here's got a bit of an alignment problem. The client brought it to me and asked me to check the alignment and see if I could make it work a little better than it is, because, well, right now it's not in very good shape. Let's take a look at this one. I have here a Tascam DA302. This is a double DAT deck that was brought in to have the alignment checked. So let's, before I even start, let's take the top off and take a look at the actual mechanism of this unit. So here's the inner workings of this unit. As you can see, it has two independent decks. They both can be removed to be worked on, and that's exactly what I have to do. Because of the way that the mechanisms are set up, they can't be simply adjusted like this. The decks themselves actually have to come out. So I'm going to remove the doors from the front first so that I can remove the decks. The doors come off, they just clip off. As you'll see, the doors just clip off like that. And now I can remove the individual decks to set them up accordingly. The decks themselves are held in place by two screws, one on either side at the base, and two more screws up at the top here that come out, and that should lift the deck right out. There's one deck, and we'll take the other deck out so that we can adjust both of them. Actually, I'll do deck one first. So this is deck number one. I've just placed it on top of the plastic protector here to guard the power supply, although I don't have any power to the unit right now. But I'm going to remove the deck from here so that I can work on it. So we'll turn the power on, and I'll hit the eject button once it goes through the startup procedure. And this will load the tape, and now I can take a listen to it and see how it sounds. Sounding good. I'm just going to get my scope on here. We'll take a look at the RF. I'm just using a plastic cover from another piece of equipment just to provide a shield here so that I can set it on and work on it. So this is our RF test point right here at the corner of the head preamp. The head wires are here. They plug into the preamp. I've got my probe grounded to the shield, and I've got my probe connected to the RF output. We're going to adjust the P1 and, or P2, I guess they call them P1 and P2 on these things. Doesn't matter. We're going to adjust the two posts here, the entry and the exit guide posts here, to give me the best flat waveform as shown on the scope. It's actually not looking too bad. It's a little bit down. Well, I'll show you guys. And then we're going to adjust this and see if we can maximize it, and then we'll do the same for the other deck. It is off a little bit. Trying to make this as sharp as square as possible here and not have any slope. Then we do the same on fast forward and rewind. Okay, deck one's actually not looking too bad there. It flutters a bit on camera because of the rolling shutter. Right on the scope, it looks a lot cleaner. I might be able to clean this one up just a little bit here. Now if I bring up my scan rate a bit. That's the exit side guide here. So it's going to try and just bring that up just a little more. Oh, I've gone down, you see. Like they're up. Oh, there we go. It's looking a little better. Of course, what's causing this here, that's just noise, right? Because the heads are only in contact for 50% of the time. Because of how the wrap is on DAT as opposed to a VCR. Of course, if you remember from VCR days, the tape is wrapped 180 degrees around the head drum. From one side here to the other. On a DAT machine, as you can see the angle of the guides here, the tape is only wrapped for 90 degrees. So there's only a smaller track that's actually drawn. There is a gap between the two heads when they're in contact with the tape. If we stop the tape from turning, you'll see that there's one head here and there's the other head over here. So when one head is making contact with the tape, which is right here, there's the head. You can see the heads underneath these screws. As you can see, this head is coming out of contact with the tape over here. Right? This is where it leaves contact from the tape. This head isn't even in position yet. So this head number one is coming out of contact with the tape. Head 2 doesn't make contact until it gets all the way down to there. So head 2 is in contact from now, and head 2 comes out of contact about there. Head 1 is still over here. That's why you get the gap. You'll see the RF, and then you'll see a lower section where there's just noise, and that's just signals that are being picked up out of the air here. If I put my finger anywhere near the preamp, you'll see on the scope what it does. So as you can see on the scope, if I just bring my hand anywhere near the preamp, even when it's not playing, it's going to pick up noise. Just like that. Okay, that's just bringing my hand into proximity of the preamp. So when it's playing, you've got your RF portion, and then this portion is where there's no heads anywhere near the tape, and that's just noise that's just being picked up out of the air. That's what's causing that. So what we want to do is we want to try and get this as square as possible here, so that we've got the best signal recovery off the tape. See, that is bad. Then if I tweak the guide, it will come up. And that is getting much better. Same for the exit side. And of course we don't want to hear any digital noise, any lost bits. Reinstall this deck, take the other one out, and we'll do the same. The deck goes back in the way it came out. They just slip in place and held in place by 4 screws. So you have to make sure that the wires are out of the way, and then the deck just drops into place. Very, very simple to service, as you can see. There's the deck down into its locked into its bracket, and then the 2 screws hold the base tabs in, and then there's 2 more screws up the top here to hold the top section of the deck in, and then the other ones come out on the other side just the same. I'm just going to push those wires out of the way. Just like that. Screws out of the second deck. Again, it lifts out just like the first one. Very, very simple to remove these to work on them. And of course these wires are a little bit short. I'm going to have to just try and get the deck underneath here, just so I can have some slack on here to work on it. This is a properly engineered unit. I love these units that are designed like this because they're designed for ease of servicing. These units here, of course, were not intended to be used in homes. These were commercial units that were designed for recording studios, and they were designed to be serviced by the typically on-staff engineers. So everything's well laid out. The board's easy to get at, the components are easy to get at on the board. The decks can be removed, swapped out if necessary, or worked on without any serious disassembly. By contrast to consumer crap, which is designed not to be repaired at any, just not designed to be repaired. That's the big difference between working on commercial gear and working on consumer gear. And this commercial gear was not cheap. This is expensive equipment. You know, this is TIAC, right? TIAC makes Tascam, but Tascam was their professional division. And just the layout, the way things are built, it shows. I've got a couple of DA40s myself. Very simple machines to work on compared to, say, some of my Sonys that I've had. Or worse, the Panasonic. Oh, you want to talk about a hard DAT machine to work on? Try working on a Panasonic. Once again, eject. This is the deck number 2 this time, and we'll take a listen to how this one sounds at first and then check the alignment. So I'll hit play on this one, and we'll take a listen to it first. Yeah, this is going to have a separate set of outputs for the second deck, which is this one here. You can hear the sounds cutting in and out on this one. This one does have an alignment problem, as you can hear, and I'll show you on the scope. It's quite bad. As you can see, the alignment is way off here on the entrance side, so let's just see if we can tweak this one. Okay, I'm just running it through some final tests now. Got it pretty much tweaked up now, and it's not cutting out anymore. So I'm going to run this thing through more tapes. I obviously can't play these, but it is working. So I'm just going to run this through some more without playing it, obviously, on the channel. And then we can put this one back together, but it's playing pretty good now, much better than it was. Waveform's not quite perfect, but it's very, very close at this point. I might try a little bit more tweaking just to get a little bit more out of it, but at least it's not cutting out now like it was before. This one was way off. This guide here was so far out of adjustment. It was actually wound all the way up to the top. So turning it counterclockwise would bring it up a bit, and then it would jump back down. It was actually off the threads. This one was so far off, I couldn't believe how far this guide was out of adjustment. But I got it really close now, so as you can hear, everything's working. So I'm just going to let this thing play, run a few more tapes through it before sending it on its way.
To the right, here I am, stuck in the middle with you. Yes, I'm in the middle with you. When you started, I was running in the middle with you.
Still working perfect here. I've gone through a few tracks so far, and everything is it's my classic rock tape here. So I thought it would be fun just to expand this so that you can understand what we're looking at here in the RF, because you know this is the RF envelope here that we're looking at. It's hard to see there when I put my hand there, but if I expand it, what we're actually looking at here, there's more information than just the data. This portion here that you see, this is actually the bits, the data bits that make up the audio. What you're seeing here at the beginning of the trace, this is what's called the ATF data, the auto track finding data, and index signals. So you've got your time code and everything that's encoded at the beginning of each track before the audio payload. So that's what you see down here. It's not showing up good on camera. I apologize for that. Just the camera doesn't resolve what I see on the scope. But I can see the distinct bands here. These are the bits. If I expand it more, maybe that makes it a little easier to see there. That's a little easier to see if I expand it here. You can see here, this is actually the payload. You've got your auto track finding payload, which is used for the tracking servos, as well as you've got any data bits, like where they would store the bits that determine whether it's a first generation or a second generation copy. That's your serial copy management bits. They're stored here in this payload portion at the beginning of each track, as well as your absolute time, which is your digital time code that is recorded on the tape. So this is actually recorded on the tape ahead of the audio payload. That's why you see some little bit of level differences here on the payload. When we go back to look at it here, this is normally what we're looking at when we're setting up our our tracking. There, the tape's now rewinding. That was the end of the tape. So now we're into rewind mode as the tape rewinds back to the beginning. Gone through this whole tape without a single drop, without a single audio dropout. Well, this one, I won't be able to play this for more than a few seconds because this is the Beatles tape. So we know if I let that thing play, we're going to have some trouble. But I'm going to listen to this one. So far, it's been sounding great. So let's listen to this one, and then I'll run a few more tapes through this thing and just continue to monitor it for a bit, make sure everything's good. This test that I'm doing now, this is my interchangeability test. So these tapes that I've got here, these were recorded on different decks. Some of these were recorded on my Sony ES75, and another one was I have a couple Sony decks. So I've got tapes that were recorded on different machines. So that way I can verify that if it can play tapes recorded on multiple machines, that I know that my alignment is good on it. And so far, 2 different machines now, and it's playing them perfect. See, this is how it looks now when I'm running a tape that's not loaded with dropouts. Levels are staying pretty much constant throughout the whole playback. This tape's been playing for about the past hour. Haven't had any problems with it. RF level is still looking good over here. Look up on the scope. RF level is still looking pretty flat. As you can see, RF level is good. Okay, I'm going to say that this unit is now repaired. I've been running this tape repeatedly. I've run a bunch of tapes through here now. I've run this tape through about 5 times, end to end. I've been searching. I try out different tracks, search different tracks out, and it's been playing flawlessly. So I'm going to put this unit back together and get it off my bench and get on to something else. I remember I got to change the audio plugs from one deck to the other on the back because the units have independent output. So let me just change the audio cords around. Audio cords have been changed. Oops. There we go, all done. Top going back on it, send it on its way. Thanks for watching. We'll catch you again in the next one real soon. Like that, it rewinds back to the top and then cues the tape slightly forward. Thanks for watching. We'll catch you in the next one real soon.